Hello everyone. This video is in continuation of lambda expressions in Java, where we had learned in detail about functional interfaces and different syntactic flavors of lambda expressions. I highly recommend you to watch that video before jumping onto this one. With that, let's talk about method references. So sometimes a lambda expression does nothing but call an existing method and seems like acting just a pass-through medium. In those cases, it is often clearer to refer to an existing method by name, and method references enable you to do this. They are compact, easy to read lambda expressions for methods that already have a name. So here I have an interface fly behavior which has a method fly, and I have test class myTest in which I have declared a variable flyway whose assignment is an anonymous class implementing fly behavior. I have another static method whose implementation is that of low flying behavior and is similar to what is present in the anonymous class. Now, if we were to replace our anonymous class with lambda expression, it would look like this. Have a look at our lambda expression. It is simply acting as a pass-through means to our method flylow. And in such cases, we can simplify the lambda expression even more using method reference. So as you can see here, it is as simple as myTest : flylow, and the highlighted lambda expression and method reference syntax are exactly the same. Let's look at another example. This time I have removed the static method flylow and have copied the implementation from that method to the anonymous class. Our lambda expression now would look like this. What about an equivalent method reference? Well, there is none. This is because here the lambda expression is not a pass-through to another method. Put it another way, you can convert every functional interface's anonymous class implementation to lambda expression, and lambda expressions can be converted to method references, but not all of them similar to what we saw in previous slide. But then every method reference will always have an equivalent lambda expression. Well, what's driving all of this? Let's find out. Well, this is driven by a simple rule that if your lambda expression takes one of the patterns, which we will talk about now, can be replaced with method reference. Let's look at those patterns. Pattern number 1. Reference to a static method. So if my lambda expression's argument list is simply passed on to a static method of a class in the body, it can be replaced via class name : static method. Let's look at some examples. So in the first example, we have no argument list, and in the body we are calling static method foo of class myClass. And as per our pattern, it can be replaced by myClass : foo. Next, we have two arguments in the argument list, and these are simply passed on to the static method bar of class myClass. Hence, it can be replaced such as myClass : bar. Pattern number 2. Reference to an instance method of a particular object. So if my lambda expression's argument list is simply passed on to an instance method of an already declared object, which is the particular object in this pattern, it can be replaced such as containing object : instance method. Let's look at some examples. So here in both of our examples, assume that we have declared an object obj earlier. So in the first example, we have no argument list, and in the body we are calling instance method foo of object obj, and as per our pattern, it can be replaced by obj : foo. Similarly, in the second example, we have two arguments in the argument list, and we are simply passing this to the instance method bar of our object obj. Therefore, we can replace it by obj : bar. Pattern number 3. Reference to an instance method of an arbitrary object of a particular type. So here, if we are calling an instance method of argument number 1 and passing the remaining arguments from the argument list, it can be replaced by its type : the instance method name. Here, argument number 1 is the arbitrary object because we haven't declared or initialized it somewhere. Let's look at some examples. So in the first example, we simply call the instance method foo of our only argument in the argument list. And as per our pattern, it can be replaced by the type foo. Next, we call the instance method bar of argument number 1 and pass the remaining arguments to the instance method bar of argument number 1. So the method reference would look like type bar. Finally, if a lambda expression just returns a constructor with the arguments passed from the argument list as parameters, then it can be replaced with class name new. Let's look at some examples. So if our lambda expression is supplying a constructor of foo class, it can be replaced with foo new. Next, we return a constructor of bar class with arguments passed from the argument list. So as per our pattern, this can be replaced with bar new. So the thumb rule is, if you see lambda expressions where they are just acting as pass-through means and fall under one of the discussed patterns, you can replace them with method references. And with that, it should be clear that every method reference has an equivalent lambda expression and the vice versa is not true. Let's look at demos for each of them to understand them better. Let's look at the pattern for reference to a static method. So here I have two functional interfaces, simple fly and complex fly. Simple fly has a method fly which takes no argument, and complex fly has a method fly which takes roll, pitch and yaw as arguments. Further, I have a class bird in which I had defined three static methods depicting different fly behaviors, namely fly, accelerated fly and fly with roll, pitch and yaw. Further, in our test case, we invoke these methods here. Number 1. Instantiate fly behaviors. This would initialize different fly behaviors of the class. We would fill this shortly. Next is fly method, which invokes fly behaviors fly method. So let's implement the method instantiate fly behaviors using lambda expressions, and the plan is to use static methods from the class bird. Let's fill it up. Let's run this code, and it works just fine. As you can see here, we are simply passing on the arguments from argument list to the static methods, and if you can refer to our pattern manual here, we can replace all these lambda expressions in the method with method references here. So let's replace them in the form of class name static method. And if you notice here, there is method of overloading for the method fly from bird class, and yes, the method reference looks exactly the same for them, and it's the job of GRE to figure out the correct assignment. Let's run this code once again, and it works just fine. Now let's look at another example from JDK itself. So let's convert a list of doubles to their floor values. Now this map here expects a function as an input, which expects a double and returns an object. So let me use the function from math class. Now floor is a static method from math class, and the lambda expression here matches our pattern. So let's replace it with method reference. And let's just collect it. Let's run this code for the final time. and the output is floor values of our list. Now look at the pattern for reference to an instance method of a particular object. So here we have the same two functional interfaces, simple fly and complex fly, from the previous demo. Further, I have the same class bird other than the fact that all the previous methods are not static anymore. Also, this time I have added another method in it which would initialize a bird instance for us. Rest of the semantics remain the same. So let's implement the method instantiate fly behaviors using lambda expressions. The plan here is to use instance methods from the class bird. So let's implement them. Let's run the code, and it works fine. Now as you can see here, we are simply passing on the arguments from the argument list to the instance methods of class bird, and hence based on our pattern we can replace all the lambda expressions in this method with method reference of the form bird object colon colon instance method name. So let's write the code again. And yes, GRE would figure out the correct assignment for the overloaded method fly here. Let's run the code once again. And the output is exactly the same from the previous one. Let's look at another example from JDK itself now. So let's print a list of strings. Now for each here expects a consumer that takes a string here and returns nothing. So let us simply print that string here. Now println is an instance method of system.out. So if you go here, so this is an instance method and of print string, and hence we can replace it with method reference. So let's just change this to system.out colon colon println. Let's run this code for the final time, and we can see the output here. Let's now look at the pattern for reference to an instance method of an arbitrary object of a particular type. So from our previous examples, I have added the argument bird in both of our functional interfaces, simple fly and complex fly. Our bird class remains the same. Further, in our test class, we invoke these methods here. Instantiate fly behaviors, it has the same job to do, initialize different fly behaviors. We'll get to it in a minute. Next is fly method, where we have created instance of bird and we pass it on to invoke different fly behaviors. So let's implement the method instantiate fly behaviors using methods from the class bird. Let's run this code, and here is the output. Now again, we are simply passing on the arguments from argument list to instance method of bird class here, and hence we can replace them with method references. So let's replace them in the form of containing type colon colon instance method. And what's the containing type here? It is the type of the first argument, which is bird. So let's re-implement the method instantiate fly behaviors. Let's rerun the code, and the output is the same. Now let's look at another example from JDK. So let's sort a list of strings ignoring their case. Now this sort utility expects an array and a comparator, which is a functional interface that expects two strings as we have a string array and an integer return type. Let's fill in this comparator argument with our lambda expression. And as we learned previously, we can replace this method with method reference. So it can be rewritten as string colon colon compare ignore case. And let's print the list. Let's run the code, and the output is the sorted list. Let's look at the final pattern of reference to a constructor. So here I have two functional interfaces, simple bird and colorful bird. Both of them have a method init which is supposed to return a new instance of class bird. While method in simple bird doesn't take any arguments, method in colorful bird takes color parameters to initialize the bird. Further, I have a class bird which has two constructors, an empty one and one taking RGB as arguments. I also have overridden the toString method here from the object class. Further, in our test class, we first call setupBirds, which sets up functionality for simple and colorful bird. This is a to-do for us. Next is instantiate and print method, which instantiates two birds and prints those. So let's get to method setupBirds. Let's run the code, and the output is as expected. And since these lambda expressions match our pattern here, let's replace them with method references. And yes, these method references looks exactly the same, and it's the job of GRE to figure out the correct assignment. So let's rerun the code, and we can see the appropriate constructors getting called and being printed. Now let's look at some examples from JDK itself. So let's convert a list of strings to an array. Now this toArray expects an int function of array type, meaning it expects a number as an input and would output an array of string in our case. Now, but we know that we can replace it with method reference. So let's do it. And let's print the list. Let's see the output. And here it is. Also, let's look at another example. In fact, a previous one where we converted a list of doubles to their floor values. Now time to collect it. Now this time let's collect it into a set, and for that let's specify a collection here. Now this toCollection method here expects a supplier, which means it takes nothing and outputs a collection. So let's use this. And let's print the set. And we can see that the output is just 2 and 3. Let's do a quick recap. So first of all, we learned about method references and saw that how it can simplify the syntax of lambda expressions even further, and that lambda expressions can be converted to method references, but vice versa is not true. Just remember that whenever a lambda expression is just used as a pass-through means, it can be further simplified by using a method reference. And finally, we saw different forms of method references with some demos. I hope you are in a better shape to write method references